Welcome back. Today, we are cracking open the hood of the most critical infrastructure in your tech stack. We are dissecting database sharding and partitioning, the blueprints for surviving the thundering herd and keeping your system alive when the pressure hits. Before we start, smash that like button, subscribe, and share this with your team. Also, check out our companion website, bitbytoken.com, your ultimate companion site for foundational concept and deep dive system design guides for software, data, AI, and machine learning. So this is a brief overview. This is particularly designed by different principles: software, data, machine learning, AI. Each of these are further available for fundamentals and example solutions. Fundamentals could include, you can search for them, for example, let's say load balancing. Each of them are available through basics, advanced, and experts. Similarly, you can always find example solutions. We have tried to provide as much detail as possible. So they will start with functional, non-functional requirement, high-level design, data models. Then we have several sequence diagram, how the calls are made, how different API endpoints will work, so on and so forth. And along with that, we have tried to provide you trade-off and consideration along with the guidance around scalability and availability. So yes, do check it out and provide your feedback. And if any of the articles you want us to incorporate in this site, please let us know. All right, coming back to this, let's get into the architecture now. Okay, every scalability journey starts with a monolith hitting an IO bottleneck. Imagine a 10 million row user table. If you query for recent logins, the engine has to scan years of data. You're doing massive amounts of unnecessary work. This is the IO tax, and it's the first sign you need to change your strategy. Internal partitioning is your first move. We split data by range, hash, or list to make your queries faster. But remember, this is purely organizational. Everything still lives on one machine. It's elegant, but it comes with a danger: the current month hotspot, where 100% of your traffic hits one partition while the rest is sitting idle. It's fast, but it's still bound to one box. When one monolith can't take it anymore, you move to the Sharded Fleet. You're now distributing data across multiple autonomous nodes. Each shard has its own CPU, RAM, and disk. The trade-off? You've met, you've just introduced the network. Cross-machine coordination is your new bottleneck, and failure domains are no longer global. They are isolated per shard. Choosing a shard key is the decision that will haunt you for years. Avoid low variance keys like booleans and avoid skewed keys like country. If 60% of user are in one place, and if you query without a shard key, you trigger a scatter gather blast radius that forces a full cluster scan. You want to aim for high cardinality and uniform distribution. How do you rebalance without killing your site? You don't just shut the server down. Use a double write or read from both strategy. Never flip that authoritative read switch until your data copy is 100% verified. Otherwise, you're just serving stale data to your users. Reliability is non-negotiable. Stop using simple modulo hashing for your shards. Plain modulo hashing forces an 88% cluster remap if you add just one node. That's catastrophic. Instead, use the consistent hash ring. By mapping keys and nodes to a circle, adding or removing a node only impacts its immediate neighbor. It's the difference between a minor blip and a total outage. To avoid probabilistic skew, use virtual nodes, or commonly known as V nodes. Even with a perfectly good hash, blind luck can leave one physical machine absorbing 60% of your traffic. By assigning each physical server hundreds of virtual positions on the ring, you average out the load and keep your cluster perfectly balanced. Node addition is a trap. When you add a new node, it starts with a cold cache. It's empty. If you unleash a fire hose of traffic on it immediately, it will crash. Use the triple thread prevention. Rate limit your migration. Shift traffic gradually, 5%, then 25%, then 100%. And always pre-warm your caches. Never operate a shard as a single point of failure. Every shard must be a replica set. One primary node and several replicas. If the primary burns out, you need that safety net to stay online. Sharding handles your scaling. Replication handles your survivability. You also need a coordination layer. How does the router know which node is healthy? You can use centralized config servers like MongoDB, but those are a bottleneck. Or you can use a peer-to-peer gossip protocol like Cassandra. Both have their own trade-offs. Pick the one that fits your risk tolerance. Distributed transactions are the price you pay for scale. If you need to move money from shard 0 to shard 1, you're looking at a two-phase commit. It's slow, it blocks resources, and is fragile. The senior advice: design your data models to avoid cross-shard writes entirely. Keep it local, keep it fast. The industry giants have their favorites. MongoDB uses collection level sharding. Cassandra is built on consistent hashing and virtual nodes. Vitess sits on top of MySQL to manage shard maps and double write rebalancing. If you're playing at their level, don't build it from scratch. Adopt the battle tested patterns. Here's your senior engineer checklist. Before you shard, ask: is query efficiency the bottleneck? Does my dataset fit on one machine? If the answer is yes, stick to partitioning. If the answer is no, use the 4 key question in the checklist to guide your sharding strategy. Always calculate your migration impact before you write a single line of code. Finally, remember the iceberg below the waterline. Partitioning is the visible layer the engine handles for you. Sharding is the complex mess beneath that can sink an unprepared team. The difference between a junior dev and a senior architect isn't just knowing the tools, it's understanding the operational reality of keeping them running at 2 a.m. So, what's your biggest 2 a.m. horror story? Tell us in the comments below. And also, the link of my site, bitbytoken.com, is also on the description below. Do check it out, share your feedback, how we can make it better. And don't forget to like, subscribe, and share, and I'll see you in the next one.